We're going to continue talking about matter and measurements, but mainly about matter. Why? Because it matters. You don't matter. Only the science matters. So, some things. First off, yesterday we were talking about, ladies and gentlemen, yesterday we were talking about different things that we needed to deal with. Now we're going to talk about the properties and some of those properties of those mixtures, elements, and or compounds or those substances. Okay? There are different ways to identify some of their properties. And now I'm also going to ask that you really expand your memory all the way back to 8th grade and your experience with the mineral identification. So, the characteristics that allows one or distinguishing properties, one that allows you to distinguish one thing from another. Those are the properties. If I gave you two solutions, how do you tell the difference? Especially if I give you ethanol and water without tasting them. Some of you have experienced ethanol. And what is it about ethanol that would allow you to distinguish it from maybe water? The smell. And so you would have to waft to see what the smell is. Because the safety method is not sticking it up to your nose and taking a deep breath.
Good memories.
Okay? Now, what makes it a little bit difficult is the next example. And how do we tell the difference between hematite and magnetite? Some of the characteristics might be telling based on the name. How do you tell the difference between hematite and magnetite? One of them's magnetic.
Oh, you can put metal up to it and see if it magnetizes.
Yeah. Now, some of you might be driving around a vehicle that has hematite growing on it.
Rust?
Better known as rust.
Oh. Go focus.
So, you have that. Now, when you look at the two minerals themselves, they both have iron and they both have oxygen. The difference between the two comes down to the oxidation states, something that we haven't talked about yet, and we will eventually at some point, but not yet. Hematite or rust looks like what color?
Brown, orange.
Yeah, kind of a orangish. And if it was a pure sample of hematite, it would have a very orangish look to it. Okay? Magnetite, however, looks very black and is magnetic. Now what gets to be, the other tricky one, how do you tell the difference between salt and sugar? Again, without tasting them, because it's chemistry and we don't taste our chemicals. How can we tell the difference? Believe it or not, how they look. Salt will look different than sugar. If you take sugar in your hand, they will look more plate-like, little flat pieces. Where sugar will look more cubic, even at the particles. Okay? And so that's the look at it. And really what we're dealing with for a lot of these are our senses. We're needing to use, to distinguish the properties, we're using our senses. Sight, smell, sometimes maybe feel. If you remember from the mineral identification, the talc felt soapy. Okay? We don't use the sense of taste since it's chemistry. Okay? But that's how it becomes. So these properties. Now these properties are known as physical properties. They can be observed without changing anything. The boiling point of water is just that. It's the boiling point. The melting point is also that. Those are some numbers that you should also know. Inherently, just, the boiling point of water, 100 degrees Celsius. The melting point of water, 0 degrees Celsius. But some people say, no, that's the freezing point. Yes, it depends on which direction it's coming from, depends on what you say. If you're going from a liquid to a solid, then it's a freezing point. If you're going from solid to liquid, then it's the melting point. It's the same point, just depends on which direction you're coming from. Other properties are that of, say, density, mass, volume. Those are, again, our physical properties. Chemical properties, well, those are the ones we like. Because it can only be observed when a substance is changed into another substance. Flammability. How do you check if something is flammable or not? You set it on fire.
Fire.
How do you know if something is corrosive in an acid? You have a little acid to it. Does it react? Does it do some of those things? Yes. Now, you've done those before as well, and usually most mineral identification, the way to identify whether something was a carbonate, meaning something that contains the carbonate ion, was taking a diluted acid and putting a drop on that sample, and it would bubble and fizz. It would effervescent. That is, meaning that as a chemical property, is a way to identify whether it's a carbonate. Because if it didn't effervescent, bubble and fizz, then it wasn't a carbonate. It doesn't contain that carbon-oxygen ion. Now, physical properties can be further divided as into intensive properties. And intensive properties, I like to call those the Yoda properties because size matters not. The amount of copper you have does not change the density. You can have a small speck of copper or a big old roll of copper tubing. It's going to have the same density. It's going to have more mass and more volume, but it's the ratio at which they are at that makes even the small copper turning the same as a big roll of copper. It's the same. A small speck isn't going to take up a lot of mass, and it's not going to take up a lot of room, so it doesn't have a lot of mass nor volume. But it's the ratio that happens. Water boils at 100 degrees, no matter what. Whether it's 1 drop or 20 gallons. You want it to start boiling, you have to get the water that you have up to 100 degrees. Now, the 1 drop takes a lot less energy than 20 gallons. That's a different thing. But intensive properties is the Yoda properties. The size matters not. Whereas extensive properties, size matters. Okay, it does depend on the amount of substance. Like I said, the amount of energy required to boil water of 1 drop versus 20 gallons is different. Right? The fact that water boils at 100 degrees is just that. The example I like to give, and for this class that we're talking to, it works because it's 4th hour and right before lunch. Banana bread. We can all agree usually that banana bread has an odor. Whether you think it's pleasant or not pleasant is up for debate and not really worth the time. Banana bread has an odor. The fact that it has an odor is an intensive property. Now, if I make the little muffins that, they're like the little baby muffins that it takes like 20 of them to even like make it feel like you actually ate something. You just make one little one of those, that you're still going to have the smell, it's just not going to be as intense. Whereas if I bake 20 dozen, which would be quite a bit, of the big like mammoth muffins, you know, the ones that you eat and you're like, oh, that was a good meal. Okay? The smell of the banana bread or the banana muffin is much more intense then. And therefore, you would think that it's an extensive property, but it's not. It's an intensive property. It still has the smell. The extensive properties are harder to deal with because of that. Now, we do go through some of these changes as well. And not only are these properties going to be there, we're also going to be changes. Physical changes are changes that don't matter on how much you have or what it is. Changing the state of matter that it has. Such as this ice cube that I have on screen. If it were to melt, it just changes the state in which it's found. It's still water. It still has a boiling point of 100 degrees Celsius, a melting point of 0 degrees Celsius. It has a certain density of somewhere of around 1, although the change kind of does that with density as well. Okay? Chemical changes, or chemical properties, kind of change the state. You burn a piece of paper, it's not going to have the same properties anymore. Your car, as it rusts, does not have the same properties anymore. Iron that is not rusting is hard. Rust, because it's combining with oxygen, becomes brittle and flakes off, even though it's more mass. Okay? So a chemical change results in something new. A physical change does not result in something new. It's the same exact thing. So we need to make sure we know, is this something new or is this something just changing of what it looks like? For chemical changes, we have to look at some other things to make sure that they are working. So chemical changes involve the formation of a substance, as we saw on the previous slide, meaning the composition's changed, meaning it's not going to be the same. There are ways to identify whether or not this change occurs. This permanent change can be a change in color, an odor or gas being formed, heat or light being released in the form of energy, meaning something feels hot or cold, and the formation of a precipitate. Now that one's a little tricky, and that one will require us to do some other things, but that is where the formation of a precipitate, that solid form, and that's going to be something as we when we go into the lab and do our lab next week, are the properties of identifying chemical properties, which might be next week or tomorrow, depending on when we read this. That will be an important part of it. These 4 ways to identify whether or not a chemical change occurs is going to be important, not just this unit, but as we go forward. And that will help us identify whether or not a chemical reaction is happening. And in some cases, as we move forward, if we don't see one of these 4 things at the macroscopic level, that means the chemical reaction isn't happening at the particulate level, which means we don't have to do some of the other chemistry that we'll be talking about at that time. So these permanent color changes doesn't mean drawing on with a permanent marker. That is a little bit different. That's kind of a different part of it. But a permanent color change would be your car going from iron to rust. That's a permanent color change. You don't get to reverse that. Gas or odor or bubbles being formed isn't boiling of water. It's that bubbling of when you combine 2 things and all of a sudden it starts reacting. A lot of people would look at the internet to the works reaction, or the Coke and Mentos. There's a chemical reaction. Bubbles are being formed off. Heat or light being released. Just burning a candle is an example of a chemical reaction. The heat and light is being given off. Not only that, there's also a permanent color change. The wick usually starts white and then turns black as the heat is being released. There's a chemical change of the wick. The formation of a precipitate is 2 solids forming, the 2 solutions forming a solid. That one's a little bit tricky, and that one usually involves a little bit more intense chemistry that we aren't quite ready to look at yet. But these are very important things that we'll be looking at in the lab, not just for one lab, but for labs to come.